Hey everyone. In this video, we're going to look at some examples of functions whose derivatives require us to use the quotient rule. As a reminder, I've written a summary of the quotient rule in the corner here. However, if you'd like to review, you can watch my video explaining the quotient rule by clicking here. Okay, so the quotient rule says if we let our top function equal u and our bottom function equal v, then the derivative is equal to u prime v minus v prime u all over v squared. So now let's look at some examples. So example 1 says take the derivative of x squared divided by x squared plus 2. So let's let x squared equal u and x squared plus 2 equal v. So then the quotient rule tells us we need to take the derivative of u, so we're going to get 2x times v, which is going to be x squared plus 2, minus the derivative of v. So whenever we take the derivative of a sum, we can take the derivative of each term individually and then add them up. So the derivative of x squared plus 2 is just going to be 2x because the derivative of 2 is 0. So this is going to be minus 2x times u, so that's going to be times x squared, all over v squared. So that's going to be all over x squared plus 2 squared. And that's the final answer for example number 1. Okay, so now let's look at example number 2. This says take the derivative of e to the x over e to the x squared. So let's let e to the x equal u and e to the x squared equal v. So the quotient rule says take the derivative of u, so the derivative of the exponential is itself, times v, so times e to the x squared, minus the derivative of v. So for this one we're going to need to use a chain rule. So the derivative of the exponential is itself, e to the x squared, times the derivative of the function on the inside, so that's going to be times 2x, and then times u for the quotient rule. So that's going to be times e to the x. And then the last step says all over v squared. So that's going to be all over e to the x squared squared. And that's going to be it for example number 2. Alright, now example number 3 says take the derivative of the natural log of x plus e to the x all divided by x plus 1. So we're going to let this numerator equal u and the denominator equal v. So then the quotient rule says take the derivative of u. So we have a sum of functions again, so we're going to take the derivative of this one plus the derivative of that one. So the derivative of the natural log is 1 over x plus the derivative of e to the x, which is itself, and I'll separate that in parentheses, times v, so that's going to be times x plus 1, minus the derivative of v. So here again we'll take the derivative of x, which is 1, plus the derivative of 1, which is 0, so that's going to be just 1, times u, so that's going to be times the natural log of x plus e to the x, and that's going to be all over v squared, so that's going to be x plus 1 squared in this case. And that's it for example number 3. So I hope these examples help you understand the quotient rule a little bit better, and thanks for watching. If you thought this video was helpful, please subscribe, like, and share with your friends.